We will see few more examples on epsilon delta definition of limit. Consider first example. Say your f of x is x and we are asked to show that limit of f of x as x tend to a is equal to a. Okay? So again, let epsilon greater than 0 be given and we want to find delta greater than 0 such that 0 less than mod x minus a less than delta should imply mod of f of x minus a less than epsilon, because here x tend to a as well as your limit of f of x is also a. Now this f of x minus a is same as mod x minus a, and you want condition on mod x minus a only. Means you want to find delta greater than 0 whenever mod x minus a lies between 0 and delta. Your f of x minus a, mod f of x minus a should be less than epsilon. And here you are straight away getting mod x minus a as mod of f of x minus a. And you want this to be less than epsilon. So this clearly suggests that I should choose my delta equal to epsilon. If I do this, then 0 less than mod x minus a less than delta, this will imply mod x minus a is less than epsilon. But mod x minus a is mod of f of x minus a, and this is less than epsilon. That means limit of f of x as x tend to a is a. Let's consider a second example. Here, let your f of x equal to x square. And we are asked to show that limit of f of x as x tend to a is equal to a square. So again, let's start. Let epsilon greater than 0 be given. We want to find delta greater than 0 such that 0 less than mod x minus a less than delta should imply mod of f of x minus limit. Here limit is a square. So f of x minus a square, its modulus, should be less than epsilon. Now let's analyze this term mod f of x minus a square. So mod f of x minus a square is same as mod x square minus a square. And this mod x square minus a square, you can write it as mod x minus a into mod x plus a. And you want this term to be less than epsilon. Remember, we want to find delta, positive delta, such that my mod x minus a lying between 0 and delta will imply mod of f of x minus a square is less than epsilon. That means I want condition on my mod x minus a. And here I have got mod x minus a. But with this mod x minus a, I have got one more extra term, that is mod x plus a. So again, what I'll do, I'll take some constant value of delta. So say mod x minus a is less than 1. If mod x minus a is less than 1, what will it imply? This will imply minus 1 less than x minus a less than plus 1. If I add a, I will have a minus 1 less than x less than a plus 1. Now note that your a is less equal mod a, and minus of mod a is less equal a. And this will imply your a plus 1 is less equal mod a plus 1, and minus of mod a minus 1 will be less equal a minus 1. And if I make use of this inequality, in this what I will have, minus mod a minus 1 less equal a minus 1 less than x less than a plus 1 less equal mod a plus 1. That means I can say minus of mod a minus 1 less than, strictly less than x, x less than mod a plus 1, and this will imply mod of x is less than mod a plus 1. But remember, we want condition on mod x plus a, and we have got condition on mod x. So consider mod x plus a. By using triangle inequality, you can say it is less equal mod x plus mod a. But mod x is less than mod a plus 1, and this mod a as it is. And this is equal to 2 times mod a plus 1. So you have got your mod x plus a is less than 2 times mod a plus 1. When you got this, if your mod x minus a is less than 1. Now remember, you want mod x minus a into mod x plus a to be less than epsilon. But your mod x minus a and mod x plus a, means mod x minus a multiplied with mod x plus a, is less than mod x minus a into 2 times mod a plus 1. And if I make this term less than epsilon, automatically mod x minus a into mod x plus a will become less than epsilon. And this will imply my mod x minus a should be less than epsilon upon 2 times mod a plus 1. And this suggests me that I should choose my delta equal to minimum of 1 and epsilon upon 2 times mod a plus 1. If I choose my delta to be this, then 0 less than mod x minus a less than delta implies mod of f of x minus a square, which was equal to mod x minus a into mod x plus a, is less than, now my mod x minus a is less than delta, and delta is minimum of 1 and epsilon upon 2 mod a plus 1. So mod x minus a I can say is less than 2 times mod a plus 1. And also remember, since delta is minimum of 1 and epsilon upon 2 mod a plus 1, I have my mod x minus a is less than 1 also. But if mod x minus a is less than 1, my mod x plus a is less than 2 times mod a plus 1. So mod x plus a is less than 2 times mod a plus 1. And 2 times mod a plus 1 cancel with 2 times mod a plus 1, and it gives you epsilon. So whenever your 0 less than mod x minus a less than delta, you will have mod f of x minus a square is less than epsilon. That means limit of x square as x tend to a is equal to a square. Let's consider the next example. Let f of x equal to 1 upon x, and we are asked to show that limit of f of x as x tend to a is equal to a if a is greater than 0. So for simplicity purpose, we are considering our a to be positive. So let's start with the solution. Let epsilon greater than 0 be given. We want to find delta greater than 0 such that 0 less than mod x minus a less than delta implies mod f of x minus 1 upon a is less than epsilon. Now mod of f of x minus 1 upon a is equal to mod 1 upon x minus 1 upon a, and if I make the denominator same, it is mod a minus x upon a into x. This I can write as mod x minus a upon a times mod x. Since a is positive, I can write mod a as a. And I want this term to be less than epsilon. See, I want condition on mod x minus a only, but here I have got mod x minus a with some extra term, which is 1 upon a times mod x. So I should get rid of this term. Now say my mod x minus a is less than a upon 2. A is positive, so a upon 2 is also positive. Now you might wonder that why I have not chosen 1 here. All the time I choose 1 here, but this time I didn't choose 1 here. See what problem can occur if I choose my mod x minus a to be less than 1. I'll have minus 1 less than x minus a less than plus 1, and if I add a, I'll have a minus 1 less than x less than a plus 1. Now here, since I want condition on 1 upon mod x, I don't know this a minus 1 is positive or not. If my a is less than 1, this a minus 1 will become negative. See, if I take reciprocal, what I'll have 1 upon x is less than 1 upon a minus 1. But if my a is less than 1, 1 upon a minus 1 is negative number. And that really will not help me to choose delta. Therefore, I chose my delta here to be a upon 2. So if mod x minus a is less than a upon 2, I'll have minus a by 2 less than x minus a less than a by 2. After adding a, I will have a minus a by 2 less than x less than a plus a by 2. And this will give me a by 2 less than x less than 3a by 2. Now if you take reciprocal, you will have 2 upon 3a less than 1 upon x less than 2 upon a. Now this 2 upon 3a is also positive. So you can say 1 upon mod x is less than 2 upon a. Now you want condition on 1 upon a mod x. So this will imply 1 upon a mod x is less than 2 upon a square. But when this happened when you assume mod x minus a is less than a upon 2. Now you want mod f of x minus 1 upon a to be less than epsilon, and this mod f of x minus a you got is equal to mod x minus a upon a times mod x, and this mod x minus a upon a times mod x you got is less than mod x minus a upon a square into 2. But when you got this when your mod x minus a is less than a upon 2. And if you make this less than epsilon, automatically mod f of x minus 1 upon a become less than epsilon. So this suggests you that your mod x minus a is less than a square epsilon upon 2. So you should choose your delta equal to minimum of a upon 2 and a square epsilon upon 2. So then 0 less than mod x minus a less than delta implies mod f of x minus 1 upon a, which was equal to mod x minus a upon a times mod x, is less than, now mod x minus a is less than a square epsilon upon 2, and 1 upon a mod x is less than 2 upon a square whenever your mod x minus a is less than a by 2. So this is 1 upon a mod x is less than 2 upon a square, and this is equal to epsilon. So whenever your mod x minus a lies between 0 and delta, you have mod f of x minus 1 upon a is less than epsilon. Now consider the next example. Say your f of x is equal to x cube minus 4 upon x square plus 1, and we are asked to show that limit of f of x as x tend to 2 is equal to 4 upon 5. So let epsilon greater than 0 be given. See, you want to find delta greater than 0 such that mod x minus 2 less than delta and greater than 0 should imply mod of f of x minus 4 by 5 is less than epsilon. You want to find such delta. So consider this mod f of x minus 4 by 5. This is equal to x cube minus 4 upon x square plus 1 minus 4 upon 5. This will give me 5x cube minus 20 minus 4x square minus 4 upon 5x square plus 1. This I can write as 5x cube minus 4x square minus 24 upon 5 times x square plus 1. Now, since I want condition on mod x minus 2, so I should have some factor of x minus 2 in the numerator. So what I'll do, I'll divide this polynomial 5x cube minus 4x square minus 24 by x minus 2. So if I do that, 5x cube minus 4x square minus 24, if I divide it by x minus 2, let's see what we get. So this factor should be 5x square, and if I multiply by 5x square to x, I'll have 5x cube minus 10x square. This minus, this plus, so this will get cancelled and you will have minus 4x square plus 10x square is 6x square minus 24 as it is. Then this you should choose as 6x. So if you multiply by 6x to x minus 2, you will have 6x square minus 12x. So 6x square get cancelled and this will become 12x minus 24. Now you should choose your term in quotient as plus 12. So it will become 12x minus 24 and this is 0. So after performing this division, you know that this 5x cube minus 4x square minus 24 can be written as 5x square plus 6x plus 12 into x minus 2 upon 5x square plus 1. So this I can write as mod of 5x square plus 6x plus 12 upon 5 times x square plus 1 into mod of x minus 2. Now I have mod x minus 2 here and I want this to become less than epsilon. But with this mod x minus 2 I have extra term 5x square plus 6x plus 12 upon 5x square plus 1, its modulus. So what I'll do, I'll take some constant value of my delta. So I'll assume, say my mod x minus 2 is less than 1. If I have this will imply minus 1 less than x minus 2 less than plus 1. This will imply 1 less than x less than 3 if I add 2 on both the side. Now in numerator I have 5x square plus 6x plus 12. Let's see. So since I have 1 less than x less than 3, this will imply 1 is less than x square is less than 9. So 5x square plus 6x plus 12 I can say is less than 5 into 9 plus 6 into 3 plus 12, and this is equal to 75. So 5x square plus 6x plus 12 is less than 75, and this 5x square plus 6x plus 12 will be greater than 5 into 1 because x square is greater than 1 plus 6 into x is greater than 1, so 6 into 1 plus 12. That means this is equal to 23. So I have 23 less than 5x square plus 6x plus 12 is less than 75. That means my 5x square plus 6x plus 12 is positive. So I can say mod of 5x square plus 6x plus 12 is less than 75. Now let's see the denominator. In denominator I have 5 times x square plus 1, and see x square plus 1 is positive. So 5x square plus 1 you can say is greater than 5 times 1 plus 1, which is 10, because x square is greater than 1. So you can say 1 upon 5 times x square plus 1 is less than 1 upon 10. Therefore mod of 5x square plus 6x plus 12 upon 5 times x square plus 1 into mod x minus 2 is less than 75 upon 10 times mod x minus 2. And 75 upon 10, you can, if you want to reduce it, you can say, if you divide it by 5, so you will have 15 upon 2 times mod x minus 2. And if you make this less than epsilon, automatically your mod of f of x minus 4 upon 5 will become less than epsilon. And this suggests you that you should choose your mod x minus 2 to be less than 2 epsilon upon 15. And this suggests that I should choose my delta equal to minimum of 1 and 2 epsilon upon 15. And if I choose this delta, then 0 less than mod x minus 2 less than delta implies mod of f of x minus 4 upon 5, which was equal to mod 5x square plus 6x plus 12 upon 5 times x square plus 1 into mod x minus 2 is less than, now mod x minus 2 will be less than 2 epsilon upon 15, and when your mod x minus 2 is less than 1, you have numerator is less than 75 and denominator less than 10. So this will get cancelled and you will have this is equal to epsilon, and hence you can say limit of f of x as x tend to 2 is equal to 4 upon 5.